Hey there, René Molenaar here for GNS3 Vault, and I'd like to show you how to solve the ICND2 assessment lab. So let's have a look. This is our topology. We have 3 different routers, and what we're going to do is take a look at the goals here. And the first thing is we're going to configure PPP encapsulation between Luke and solo. So let's give it a shot. This should be for PPP. And I'm going to enable a debug so you can see what is going on. And as soon as I type in encapsulation, you can see that it's setting up the PPP link. The next step, PPP chap with a password of Vault. The first step is you need to specify username and password, and the username should be the host name of the other site. There we go, and then we'll enable it on the interface, and we'll do it like this. Let me show you another debug. PPP authentication chap, and as soon as I type this in, you can see it is negotiating, checking the username and password, and this is what we are looking for, success, which means that my PPP authentication is working. Okay, on to the next step. Configure OSPF area 0, but on router look we are going to use a single network statement. Which will advertise everything like this. Router Han Solo, we're going to use 2 different network statements. This one will take care of all the physical interfaces, and this one is going to advertise the loopback. And on router Chewbacca we're going to use 3 network statements, but we're not allowed to use this wildcard. So this is another method. Here we go. Ensure we have reachability. Everything should be pingable. Okay, so what I'm going to do is just try if I can reach the loopbacks. And if I can reach the loopbacks, then it sounds good to me. So I can ping everything. Change the router ID for router Han Solo. This is how we do it. But keep in mind you need to reset OSPF before it takes effect. Okay, traffic from router Han Solo to Chewbacca should use the link between Luke and Han Solo. Use the bandwidth command. So what I'm going to do is, if I do a trace from Han Solo to the loopback of Chewbacca, and you'll see that it will take the directly connected serial interface to Chewbacca to get there, since this is the shortest path. Now I'm going to change the bandwidth, set it to a very low value. And you'll see that it will take a different path. You see that it's sending traffic to router Luke, and then it will go to Chewbacca. This is because bandwidth is used to calculate the cost of an interface for OSPF. And you can see that this is the cost right now. And if you do a show IP route, you can see over here that this is the cost if we have to go through router Luke. So this is a much better path. So that is the bandwidth command. Next thing, we're going to use the cost command. So get rid of the bandwidth. And I can do the same thing by applying a cost. You can see here, if I do a show IP interface, here you have the cost of 500. And you'll see here that it has a cost of still 129 by going through router Luke to get to Chewbacca. So using cost is another method. Next part. Configure clear text authentication between router Luke and Han Solo. This is how we do it. And of course make sure you do it on both sides. The best way to check if it's working or not, of course check if you have neighbors for OSPF, but if you do a debug IP OSPF packet, you will see information like this. This one is coming from router Han Solo, and you can see authentication 1, which means type 1, clear text. This one is coming from Chewbacca, authentication 0, which means no authentication. And you can see my neighbor is up, so authentication is working. Next part, MD5 authentication between Han Solo and Chewbacca. Keep in mind there's a different command to configure the key for MD5. And let's do another debug. This one is from Han Solo. No authentication. And we should get some packets from Han Solo. Oh crap. Gotta love IP domain lookup. Okay, so I lost my neighbor. So what did I do wrong? Let's have a look. Serial 01. Oops, I accidentally configured it on the wrong interface. There we go. That should be better. Okay, so between Luke and Hand Solo is okay again. And let's see what we have here. Okay, my bad. I've been configuring this on the wrong interface here as well. Because it should be between Han Solo and Chewbacca. Okay, my bad. I took the wrong interface. There we go. Okay, that's better. So what do we see here? Let me stop that debug. This packet is from Luke, no authentication. This one is from Han Solo, authentication 2, which means MD5, and you got a key ID. So it seems my authentication is working. Next step, OSPF hello timer. All routers, set it to 6 seconds. This is how you do it. Make sure it has to match on all routers, otherwise you're not going to become OSPF neighbors. Here we go. Next step. Advertise a default route in on router Luke. Don't use a static. This is what we are looking for. Default information originate always. And if you look on any of the other routers, you will see this default route being advertised by router Luke. Optional. If you look at the routing table, you will see the loopbacks are /32s. Change them so they reflect the real subnet mask. And I'm going to do this for one loopback. So let me show you the loopback of Chewbacca, which has a /24. Now if you look in the routing table of Han Solo, you will see that this loopback is advertised as a /32. And the reason why this happens is because OSPF configures the loopback as a network type loopback, which will automatically advertise everything as a /32. So I'm going to change it and set it to a different network type. For example, point to point. And now you will see that it advertises the network with the correct subnet mask as a /24. Alright, what else do we have? RIP version 2 between Luke and Chewbacca. Advertise the loopbacks. So Luke and Chewbacca. The loopbacks, here we go. Here we go, so this network. Let me show you a debug. So you can see that we are receiving or sending packets. Okay, so for example, it's sending this update to the serial interface. And we are receiving an update. So you can see that the RIP is working. And the next task says that ensure you see RIP routes in the routing table for those two networks. You're not allowed to make changes to OSPF. So if I do a show IP route, you don't see anything from RIP, since the administrative distance for OSPF, which is 110, is lower than RIP, which is 120. So what I'm going to do is go to RIP and change the administrative distance for these two prefixes. And I'll change it to 100, so it's lower than OSPF. Now you can see that the OSPF entry has disappeared and we have a RIP entry. And the reason you see RIP, because the administrative distance is 100. Let's do the same thing on router Chewbacca. Here we go. And now you can see this entry in the routing table. And this is funny, you also still see this OSPF entry, 2222/32. The reason you see it is that I didn't change the network type of the loopback. So the OSPF entry is still advertised with a /32. And the RIP entry has a /24. Okay, router look. When we do a debug, you can see that it sends information to the loopback. and I still have a debug. I have a debug here for RIP, and you can see it over here. Sending version 2 update to the loopback, ignoring version 2 packet from the loopback. So routed Luke is trying to talk RIP to himself, and we're going to change this by setting the passive interface command. What else do we have? Configure EIGRP on Chewbacca and Han Solo. Advertise the loopbacks as well. Let me think. Chewbacca and Han Solo. Okay. Okay, so you can see here that my EIGRP neighbor is working. Here it is. So we have an EIGRP neighbor. And the next thing is that we're going to create additional loopbacks. This one on Chewbacca and 2.1 on Han Solo. And we'll advertise it in EIGRP. Let me think which AS number I took. AS number 1. Okay, oh, there's one mistake I made. Advertise the loopback 1 interface on router Han Solo, so I shouldn't advertise it on Chewbacca. Here we go, let's get rid of it. Now what I'm going to do is ping 172.16.2.1 from Chewbacca, and let's see if it's working. And you can see that it's working. And you can see that this entry is, we have learned it by using EIGRP. Now I'm going to ping it again. Small error here, this should be 172.16.2.1, but I'm going to source it from the loopback interface. So let's see if that makes any difference. As you can see, if I try to ping it from this loopback interface, it's not working, which makes sense because I didn't advertise it in EIGRP. Now I'm adding it in EIGRP. And let's see if I can still ping this network. Now, as soon as I add this network in EIGRP, I'm unable to ping the other side. From Han Solo I also can't ping it. So what do you think is going wrong here? It's a good question, let me show you. If we look at the routing table, you see a couple of things from EIGRP. Let's just look at the EIGRP information. And you can see that it has created a summary, and you see 172.16.00/16 in the routing table. The reason is that by default EIGRP is class full, which means that it does not send a subnet mask. In this case, router Han Solo and Chewbacca, they both have a class B IP address on their loopback 1 interface. So we have a problem here. This is a discontinuous network, and I'm going to change EIGRP so it will send the subnet mask along with its routing updates. So no auto summary. Now if I do a show IP route EIGRP, you can see that instead of the /16, now it has learned a /24, and I should be able to ping it, even if I source it from loopback 1. And the same thing for router Han Solo. So make sure you disable auto summary, so it will send the subnet mask along with the routing update. What else do we have? Change the configuration on Han Solo and Chewbacca, so reliability is also used as a metric. By default only bandwidth is used and delay. And what we are going to do is enable reliability as well. Let's set reliability. Yes, reliability. Now how can we do this? And let's take a look. Where was it again in EIGRP? Now I have to think a little bit about this one. It's not this one. Or I think it is. Let's try it out. You can see right now that the metrics that EIGRP is using, these are the K values. K1, bandwidth, K2, load, K number 3 is delay, 4 is reliability, and number 5 is MTU. So we are just going to play with it a bit. I'm just going to enter a couple of numbers. So metric, delay, reliability, let's just enter something. Load, okay, this isn't it, I'm looking for something else. Let me think. It's not default metric. I think it's this one. Here we go. This is where you can set up the K values. And you can also specify the weight, which means what EIGRP will use. Is bandwidth more important over delay or whatever? So I'm going to enable K1. I'm not going to enable K2, which is load. K3 is delay, reliability. There we go. This is it. You can see the neighbor is disappearing because the weights are not the same. Let's change the weights here as well. And you can see my neighbor is back. And if we do a show IP protocol, you can see that bandwidth is enabled, delay and reliability. So metric weights is the command. One more step. Authentication for EIGRP, keychain vault, key ID 1 and the key string should be welcome. That's the keychain. And let's copy and paste this one. And now we need to enable it on the interface. And I'm setting it to MD5. Here we go. So you can see I have created a keychain, specified a key, enabled it on the interface, and now my neighbor is back up. And that was the last step in our list with goals. I hope you enjoyed this, and if you want to do some more labs for your CCNA, make sure to check out GNS3 Vault. If you have any more questions, please leave them in the comments. And for now, thanks for watching.